Guys, Professor Calculus is here, and today in this video we're solving the integral of erf of x ln x dx. Before that, make sure to like and subscribe, and as it is free and you can always change your mind later, but for solving it I'm gonna go ahead first and introduce a parameter a, which is gonna make my integral erf of ax ln x dx. And if I find I of 1, that means that I have found the integral that I was looking for. So let's go ahead and differentiate I prime of a by taking a total derivative of the integral that we have here from 0 to infinity of erf of ax ln x dx. This is going to move inside, and it's going to make the derivative a partial derivative according to Leibniz integration rule. So we're taking partial derivative of this thing here. So since we're taking partial derivative, these are constants, and just this is the thing that we should take a derivative of. So it's going to be from 0 to infinity of the derivative of erf of x is negative 2x root pi e to the negative a squared x squared ln x dx. And if I sort it out a little bit more, it's going to be 2 over root pi, the integral from 0 to infinity of x e to the negative ax squared ln x dx. Now I'm gonna introduce a variable u, that is ax squared, which is a squared x squared. Du therefore is gonna be 2x a squared dx. And dx is gonna be x dx here is gonna be du over 2a squared. So and my x would be u over a squared square root of, which is root u over a. So if I do this substitution here, I prime of a would be negative 2 over root pi, the integral from 0 to infinity of e to the negative u. Ln of x would be ln of root u over a. Dx would be x dx would be here, which is du over 2a squared. So these twos are going to go away, and I prime of a is going to be negative 1 over root pi a squared, the integral from 0 to infinity of e to the negative u ln of root u over a du. I prime of a therefore is going to be negative 1 over root pi a squared, and according to the property of logarithms, I can say that this is ln root u minus ln a du. And I prime of a is negative 1 over root pi a squared 0 to infinity of e to the negative u. This is gonna move down here, ln u plus 1 over root pi a squared from 0 to infinity of e to the negative u ln a du. So this is gonna move outside. So let's sort this integral first. Negative 1 over root pi a squared 0 to infinity e to the negative u ln u du. So this integral, this portion here, has an exact value which is equal to Euler's constant, denoted as gamma, negative gamma. So this is equal to negative Euler's constant. So writing my integral again, it's going to be gamma over 2a squared root pi plus 1 over root pi a squared ln a 0 to infinity of e to the negative u du. This portion of integral is going to go down to 1. You can try it yourself. And thus I prime of a is going to be gamma over 2a squared root pi plus ln a over root pi a squared. So I have to integrate it to get I of a. I of a is the integral of gamma over 2a squared root pi dA plus ln a over root pi a squared dA, which is going to be gamma over 2 root pi 1 over a squared dA plus 1 over root pi ln a over a squared dA. And according to power rule, this is going to be negative gamma 1 over negative gamma over 2 root pi a plus 1 over root pi. So if you integrate this by using integration by parts, you're going to be getting, I'm just going to write down the result, ln a over a root pi minus 1 over a root pi plus c. Now to find this constant of integration, I'm going to let a go down to infinity, and since I of infinity is 0, I can say 0 is equal to the limit as this side approaches infinity, which is also 0. So as this side approaches infinity, this limit is going to go down to 0. So is equal to 0 plus c. Thus c equals 0. So I of a equals negative gamma over 2 root pi a plus ln a over a root pi minus 1 over a root pi. Thus our integral from 0 to infinity of erf of ax ln x dx is this creature right here. And if I plug in a equals to 1, I'm gonna get erf of x ln x dx to be equal to negative gamma over 2 root pi ln of 1 is 0 minus 1 over root pi, which simplifies to negative gamma over 2 root pi minus 2 over 2 root pi, which is negative gamma plus 2 over 2 root pi, which is the integral from 0 to infinity of erf of x ln x, which is ln x dx, and that is the final form of this integral that we had gotten. Thank you for watching this video. Please like and subscribe, and I'll see you next video.